In this video, I'm going to show you how to create the joints on the advanced gear set. This is meant to go along with the custom gear train documentation, which is the beginning of the planning of your custom gear train. This is sort of leading towards the end of our course on gears, and so at this point you'll be applying what you know in terms of simple and compound gear trains to make your own custom gear train. And you might want to add in some additional gears, and so I was going to go through how to download and assemble those now. So at the bottom of the assignment here, there's a couple of links. This one says, or leads to the gears as part of VEX, which if we scroll down to the bottom, we'll see here on this tab, CAD files. And then here we've got different gears, and we can go down to the advanced gear set. I'm going to start by downloading all of these. So I'm just going to click download on each one. It's going to automatically download those for me. Get each one. And check to see. Okay, it looks like that's all done. So I'm going to, now upload them into Fusion. So within my Gears folder, I've started to make, or Gears project, I've begun to make folders. And so I've got one for advanced gears here. It's been made using the new folder. And so I'm going to upload the parts that I just downloaded from the VEX website by clicking on upload and then going to select files. I'll click at the bottom and drag up to get everything. And click open. And then upload. And this might take several moments because I've done them all at once. But then once they are there, I'll have everything to go through the assembling them and putting the joints on each of these. So I'm going to start with the 24T bevel gear. I'll double click that to open the part file, because here I want to actually edit these parts, make permanent edits to them to make them more useful. And so here is the bevel gear. This is used for making a 90-degree turn between gears, right? And so it changes that rotational energy force, changes it the direction 90 degrees, or you could say it's normal to each other. It's a mathematical term for a perpendicular, a 90-degree angle. The first thing I'm going to do here is make these a little bit more like the VEX gears. They're currently steel, which is the default for Fusion. So these gears didn't really come with type information. And so as Fusion opened them, it just defaulted to steel. And so I want to make them plastic to be like the gears from VEX. And so I'm going to go and find the plastic in the materials area. And then I'm going to click and drag that on to find it works better if you do it in this browser right there. And so I got both of them, it looks like. Click there. Alright. Just checking. And so those are now both made out of plastic. And so I'm going to go back to modify again. I'm going to go to appearance. And then you have different appearances here. And then including paint, which you can click on to expand. So if you expand paint, here this arrow means that they're not downloaded yet, right? And so if you have some of these arrows, you'll need to download the one you wanted. And so I've already downloaded the green. I'm just going to drag it on to, again, the part within the browser. Seems to work best for this. And then I'll close that. And so now I've got those made out of plastic and green. This is sort of similar to the way they come from VEX. And so I'm going to hit Control and S to save it. So I've saved it. You could also click right there. And at this point, I'll close the data panel briefly. Now, with these, we just need to create the Revolute joints and then motion link them together. So I'm going to hold Shift, hold the Shift key, and then press J which is the shortcut, the keyboard shortcut for the as-built joint, which I'll switch over from rigid to revolute. And I'm going to choose one of the gears, and then click on the top level component in the browser, and then it wants the snap. That's where it's going to revolve around. So I'm going to hover over this face, the circular part of the face, until I can see that center point appear. You see I can't click it without holding control, and so once I'm over it, if I hold the control key down, when I go to click on it, it'll remain there. And so I'm going to click on that right in the center. And so that revolute joint is done. I'm going to do the other one now in the same way, holding shift and then pressing J, clicking on the gear, clicking on the top level component, hovering over the face until I can see the midpoint, and then holding the control key and clicking the center for that one to begin to revolve. Now they both have their revolute joints. I just need to do the motion linking between the two joints by going to Assemble, Motion Link. I can click one joint and then the other. And the only thing that's wrong here is that it needs to be reversed, and so I'm going to click on this reverse checkbox right there. And as you can see, they move and line up very nicely. I'm just going to press OK. So then I'll hold Control and S. And so now these joints are ready for use. You could drag this part into another project, right? A larger project you might have, and you'd already have those joints assembled, pre-assembled, ready to go. So that is the bevel gear 24T. I'm going to open up my data panel again, and let's make sure that I save that before closing this file. Next, I will go to the rack gear and pinion. I'm going to not drag that, I want to double click it. In this case, once again, I'm wanting to edit this part. And so the first thing I want to do is isolate this rack gear by itself, because if I were to use this, I'd probably want to use more than one of the rack part. And you can use these lined up one after the other. And so what the rack gear and pinion is for is changing the rotational motion of the pinion gear into a linear motion of the rack. Right? And so linear is like a line, it's going to move back and forth like that, and that can come from the rotational energy turning back and forth, or it could just go in one direction, but in general it just goes in a straight line, and whereas this one goes around in a circle. And so there's a couple little metal inserts inside of a plastic piece, something to kind of be aware of. And the first thing I'm going to do is sort of separate these parts out. First, I will go to my 12-tooth gear. I'm going to right click on that. I'll just export that into the same folder here. So I'm going to need to uncheck the export to my computer if I have that, because I wanted to export it to the cloud. That means it'll end up in my data panel there. So I'll click on export, have that sort of as a separate part, 12-tooth gear. And now I will go ahead and delete that 12-tooth gear from this file because I'm wanting to isolate it. So I'm going to delete that. And then I will go to File, Save As. So I want to save this as a new file. I don't want to overwrite my original just in case I need it. But I want to also isolate the rack so I can use multiple ones pretty quickly. So I will just delete that beginning part and call this new one rack gear. That's fine. Like so. The next thing I'm going to do is create some as-built joints between the metal inserts and the plastic rack. And so I will hold Shift and press J. And these need to be rigid. They're not going anywhere, but it'll hold it in place as it moves back and forth. And so click on um, one of the rack and then one of the nuts. You press OK. Then Shift and J again, the rack and then the next nut. Okay. Then Shift and J, and the rack and the last nuts. Press OK. So all those joints are there. At this point, I'll go ahead and go to Modify, and this is where I'm going to change the rack to plastic, and so there's the physical material. And I can, at this point, close my data panel for a little bit while I work. And so I'm going to go down and find, I like just using regular plastic, generic plastic if you will, right here. And so I'll drag that over to the browser and drop it on the rack. And so now that's the plastic material. It's still got the metal inserts. And so then I'll switch, go to modify and get the appearance one. Change this color to that same green color. I think these might come in red for them, but I'm just going to do them all green for now. That's fine. And so then I'll do Control and S to save. So this part now, I would say, is ready for use along with the other one, but instead of editing it anymore, I'm going to open up my data panel again. And I'll close this, and then what I want to do is in this new file, go ahead and just drag in that 12-tooth gear. And so it wants me to convert to an assembly. This is part of the updated change. Now they have a little bit more separation between the different types of workspace. Whereas, so with the assembly, they prevent you from modeling within that, creating new objects. So you're only meant to kind of assemble, put them together, which is what I'm doing. So that'll be fine for now. I'm just going to go and convert to the assembly. Then look at that. And so that's approximately at the origin. I'll leave it there for now. It should be in the right space, or just about, relative to the other one. I did accidentally forget to unground it, so I can right click on that and choose unground from parent there. Now I'll allow it to move later when I get there. And so then I'll drag in my rack gear. And does look like I'm going to have to adjust the position of these, because now didn't capture that position quite right, and so go ahead and drag this up a little bit, and see if I can look at my front. Yeah, I'm gonna rotate this around a little bit in different ways, and so I think what I'll do is I'll rotate. Actually, I'm happy with this one. I'm gonna just pull this up, and then I'll rotate the gear, the pinion gear around. And so I'll press OK. Then for this 12-tooth gear, I'll go back to it. Not happy with where that was, and so I right-clicked on it. I'm going to choose Edit Initial Position. Right? So I'm going to go back to where I'd originally set it. I'm going to rotate that 90 degrees. Press OK. Now I'm going to look at that, and so probably the height is getting pretty close. Does look like this part is too far back, so I will right click on it. I'm going to go to Edit Initial Position again, and then just pull that forward, get them pretty nice and aligned. That looks good. Still a little bit high, so I'm going to pull that down until they looks pretty close to being interlocked. That's good. And now I'm going to start jointing things together. And so I'll press Shift and J and switch that to Revolute and choose this one. And then, because we are in assembly mode, actually I'm going to need to, well, it should work still. I'll see. So I got that top level component, which is still unsaved, but I believe it'll still work. And so I should need to just get the snap. So hover over the face, hold the control key, and then get this center there around which it'll rotate. Press OK. See how I can fit this together. Looks like the rack is a little bit too low. So I'm going to go and raise that up by, again, going to rack, right-click on it, edit initial position. I'm just going to pull it up a little bit, press OK. And it looks alright. It could be a little bit more tightly fit, I think. Edit initial position. Very close there. Maybe here. It doesn't have to be perfect. That's probably about as good as I can get that. And so, the next thing to do will be to set a joint on the rack. And so here, actually, I should go ahead and save it at this point. I'll do Control S, and because I haven't saved it, it'll ask me what I want to save it as. I'm going to name this rack and pinion. And this would be where I start. If I wanted to use this, I'd pull in this piece first and then just attach additional racks to it as needed. And so then, in order to do, oh yes, the slider joint comes next. So I'm going to do hold shift and press J for as built. I'll switch the type from Revolute to slider. And then for the components, I'm going to choose this one, the rack, and then I will choose the top level component. And then it wants to know the snap, that's sort of where along it's going to be sliding, so I'm going to choose that center point. And let's preview the motion here. It seems like it's moving these back and forth right there. And so that's because I'm in the wrong plane here. Currently I'm on Z-axis. I think I probably need X-axis like this. Even though those inserts don't look like they're moving, they're rigidly attached, and so they'll move whenever I finish making the joint. Then I would want to set the distance here, and I can kind of see it previewing how far. It looks like it's pretty close to the distance I want to get it, which looks like it goes between negative 0.9 to positive 0.9. And so I'm going to try negative 0.9 to positive 0.9. Let's see, watch that. Could be a little bit further along each way, so I'll make that 9.1. Check that. Maybe 9.2. Oh. 0.91. I'm going to change it to 0.93, I think, is probably going to be a good number. One more gear over 0.95. 8.96. Getting pretty close. 8. 1 inch. Oh, not 100 inches. 1 inch. Alright. I guess I overthought that too much. It probably should have just been 1 inch. Either way, looks pretty good. Alright, and so we can preview that. It's going to go back and forth at about that distance, which seems about right, almost to the end. Your particular case will vary anyways, and so I'm going to press OK. And so now I can slide each one of these sort of separately of each other. And I'm going to want to align them somewhat like that. And actually, let me keep that at 0. Maybe then rotate this one just a little bit instead. And the next thing to do will be the motion linking. So I will go to motion link, capture position, and then I'm going to click on that one, and then my slider. You can see it starts it up. The real question though is how much it should spin for each way. And so currently the wheel's going around 360 degrees, whereas the slider just goes back and forth its full distance. But really, I need to come up with the distance that it will go on each tooth, right? And so within 360 degrees, how far does it go? So I've got 12 teeth on my wheel, right? 12 teeth here. And so I could measure these gaps, right? 12 teeth worth of gaps. So I'm going to press I for measure, and I'll just start at one of the teeth, right? I for measure. I'm going to click at that point right here at the beginning. I'll count my teeth. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's the 12th tooth. I'm going to come out all the way to the end there. So it tells me the distance of that 12 teeth is 1.579. If I just clicked on that distance, which is over here in the option box, it'll copy it to the clipboard for me. Close that. And so then I can go back to motion link, capture position, get my two joints. And so the distance that it goes in 12, I can change here, B. And then I just gotta reverse that animation, and it looks like it's going pretty well now. I'll press OK, and as you can see, now the gears interlock with the rack as it's rotating either way. So that's how you set up that joint, just like that. And so I'll get that centered, and then save it, and be done with that one. It's ready for use later. And I'll open up my data panel and close this out.
Next, I'll do the joints on the worm gear and wheel. So I'll double click on the worm gear and wheel part to open it in Fusion. And so we've got it orientated like this currently. You need to be on the right side to view it. Here's the worm and the worm wheel. The worm, like the rack, is made so that you can put multiple ones all together on a shaft if you would like to. And this is similar to the bevel gear in that it can transfer rotational force in one plane to another plane adjacent to it in a normal direction, sort of a 90-degree turn there. These can also apply a lot of torque to something. And so the way that we're going to do this is by putting revolute joints on both of these, and so that when one spins, the other spins at the right time. But first, let's separate these as we did with the other one, with the rack. I'm going to close my data panel for now. And the first thing I'm going to do is right-click on my worm wheel, and I'm going to go to Export. And I'll put that on, check my export to my computer, leaving export to a project in the cloud. Hit export, and so that'll appear in my data panel here. I'm going to do the same thing for the worm. I'm going to right click on it. I'm going to export it. Export. And then unclick this one, and it automatically checks the export to a project in the cloud. That means it's going to put it into my folder here, my project folder for this, the Advanced Gears folder. The reason why I'm doing this is because that way it kind of preps it before I do these joints. Right, I want to keep this part especially separate so that I can add as many of them as I would like without having these joint relationships and other modifications done, right? And so I put those into two separate files. Now I'm going to close this one. I'll open up the worm wheel first. In this one, I'm going to go ahead and go to Modify, Physical Material. I'm going to change this over to Plastic. And choose Plastic. I like just using the regular plastic right here. So I'm going to drag that onto the component in the browser to apply it. I'll close it. I'm going to go to Modify, Appearance. And I'm going to use the paint under the green. I've been using the green glossy paint. I'm going to keep doing that. It looks like I have to download this. Since the video doing the last part, I've reinstalled Fusion, and so now I had to reinstall in this color. That's done. I'm going to drag it onto my components to make that green. And then I'm just going to save that so that part's ready to go. And then I'll close it, and I'll choose the worm part. Similarly, start by going to Modify, Physical Material, Find Plastic, and then drag it onto the component level to make that plastic. I'm going to go to Modify, Appearance, and drag the green glossy color onto my worm gear there. Close that. And so there's the worm finish. I'm going to go and press and hold Control and then tap the S key to save that. And so now that's saved. With those both saved, I'll now drag them into another one. And so it's asking me about an assembly. I'm going to convert that to assembly. So at this point, I'm just going to be assembling these gears. And so I've got that orientated towards the front, and I'll also go and uncheck the ground apparent here to allow it to move freely of this top level component. And click OK. Next, I'll move on the worm part here, which is currently hidden this direction. I'm going to turn off the visibility of my worm wheel. And I like to have this orientated towards the front. And so I'm going to rotate this 90 degrees first. And go back towards my front view. Turn on the visibility of my wheel. I think I want to keep the worm centered around the origin, so I'm just going to leave that there. I'm going to go back to my worm wheel, and I'm closing the data panel here so there's more room. So I'm going to right click on the worm wheel, and then I'm going to go to Edit Initial Position. This is an alternative to doing a move. I think it's a little bit better because it doesn't clutter up your timeline as much. And so I'm going to press OK. And this looks like it's still a little bit too close. I'm going to do that again. Edit Initial Position. Maybe tick it up one more click. I can fit it a little bit better at the end, but that should be good enough for now. So at this point, I'm going to go and save this by pressing and holding Control and then tapping the S key. I'm going to name this worm gear, like that. Save it. And now I'm going to apply the joints. So I'm going to press and hold Shift and then tap the J key. I'm going to switch my type from rigid to revolute. And I'll click on my worm wheel and then the top level component. I'm going to hover over the face and while holding the Control key, I can then move to the center point here. Click on that and it'll start rotating. So that's what I wanted from that one. Do the same thing with the worm part of it. So I'm going to hold the Shift key and tap J. Now it's already on revolute. So I'll click on this and then my top level component. And then I'm going to need a snap. And so for my snap, I'm going to use this right here. And actually, it looks like that is not in the right place yet. I'm still a little bit side. I should check that before. And so I'm going to cancel that joint because once I make it, it's not going to move freely anymore. And I'm going to move this piece to center it at the origin. So I'm going to do that by going over to the worm. I'll right click on it and choose to edit initial position. I'm going to move this down to the center. There we go. So my dot's lined up there. I can zoom out. That's a good alignment, so I'll press OK. Alright, so now this one's ready for its joint, so I'll hold the Shift key and tap J. Click that component, and then click the top level component, and then I need that snap point, so hovering over the face until the midpoint appears, and then I will hold the Control key, which keeps the midpoint in place for me to go click it. So that's now revolving correctly. Now I have both the revolute joints. The next thing I'm going to do is adjust my worm a little bit so I'm clicking and holding on it and just dragging it down. That kind of rotates it, spins it, which causes it to shift the position of those threads. It looks pretty close, maybe a little bit too close to one side, right about there's where I think it's closer to the middle. It's pretty good. I don't need to have perfect contact, just kind of get it close for the modeling purposes. And so the next thing I'm going to do is press and hold Control and then tap S to save it. Now it's time to do the motion linking. And so I'm going to go to construct, and or not construct, sorry, assemble relationships. That's what it is now. So now in the new updated version, now these things will fall under relationships, and I'm going to choose. Actually, no, it's under motion. Sorry, I guess they've got those separated now. So now I'm going to go under motion, then motion link. That's it. And then capture the position. I'm going to get the revolute joint on each of the gears, like so. And I think they're currently spinning opposite of the way they should be going. And so I'm going to click on the reverse button there. Now, they're going the correct way, but the top one needs to go much slower. And so each time the worm spins around once, this gear should move over one time, or that length. And so I can divide 360 by the number of teeth on the gear. So I'm going to divide that by 24. And you can see now it moves smoothly and stays consistently interlocked with the gear. So I'll press OK on that. Now I've got it so that the worm and the worm wheel spin together. Usually in this application, you'll have the wheel spinning the worm, or rather the worm spinning the worm wheel. So the worm rotates around. You might twist a handle that's connected to the end of it, and it helps crank this down, adding a lot of torque to it. And there's other configurations. We could also have it set up so that the worm wheel is able to move horizontally across the worm is one option. We could also set it so that the worm wheel, or the worm itself rather, this bottom part, could also be set to slide back and forth. But the most common configuration, and the one that's going to need to be true every time, is just this joint that every time it rotates, it spins. So each time the worm spins around 360 degrees, the worm wheel will advance by the distance of one tooth. And so I'm going to now press the Control key and then tap S, save it, and close that one. That one's complete. Next, I'm going to do the differential gear here, so I'll double click on that. This is the last one. Probably the most complicated, but also the most interesting. These are used within cars most commonly to allow the wheels to spin at different speeds. We'll see how that works whenever I am finished putting the joints on it, but for now I'm going to start by switching all my parts to plastic. So I'm going to go to Modify, Physical Material. I'm going to look for plastic, and I will drag that over onto my top level component here in the browser to get everything to change to plastic at once. I can close that, and then I'm going to go to Modify and Appearance because I want it to be that green color. And I find my green color, and I'll drag it and put it on the top level component to get everything green, and hit close. And so I'm going to hold Control and tap S to save it at this point. Next, I'm going to start doing the joints. So starting with this one at the bottom. Now, this gear on the differential housing is the only one you need within the differential. This is the only gear you consider as part of the gear ratio, and so whatever gear system is attached to this might be your input, and so that would be it connected to somewhere along in this plane. And this gear has 36 teeth. So if you start with just a 12 tooth pinion gear on your motor, you would have a 3-to-1 ratio, giving this 3 times the torque but 1/3 the speed. So I'm going to press and hold the Shift key and tap J. I'll get to this component here, and then my top level component, and then I will hold over the face there until I can see the midpoint, press and hold the Control key, and then click on that center point, which will get it spinning, and press OK. Next, I'll do the other joints on these bevel gears. And so unlike that gear, all of these gears will be jointed to the housing, not the top level component, allowing them to kind of move with the housing. So I'm going to press Shift and hold, or press and hold Shift and then tap J. I'll click one of the gears and then the housing, and then it's going to ask for the snap, and so I might need to rotate a little bit to be able to get to that. Press and hold Control and get the snap there. It's okay. I'm going to swap to the other one. I'm going to hold Shift and then tap J, get that bevel gear, and then the housing, and then do the snap. Okay. And finally, Shift and then tap J, gear, housing, and then hold over the flat area, press and hold the Control key, and then get the center point there. Now I need to do the motion linking between these gears, and so I'm going to go to Modify, or not Modify, Assemble, Motion Link. I can click on one joint and then another, and I will reverse these, and that's all it needs to get them to interlock and spin correctly, so I'll press OK. I'm going to do the same thing again for these two. So Assemble, Motion Link, get this one and this one, and then I will reverse them and press OK. And so now everything should spin correctly, and we can look at how this will work. I'm going to start back at my front view, not the best view, so perhaps I think it makes the most sense to me to orientate it like this. So the way that this works is that you can imagine a axle running through this way and connecting to one wheel out where the mouse pointer is, another axle running this way connected to another wheel out over here, and then also on the side here in this plane would be where the driving gear would, or gear train would appear. And so whenever this one is running, like if you're driving in your car and both wheels are spinning at the same time, we can spin this one, right? Now, you'll see though that if you grab one of them, I see each of these is able to spin at slightly different rates, as it is also spinning this way, with this gear at the bottom adjusting to compensate for any difference in length they need to travel. I can also click and drag this one right by itself, so pretty much independently of the one on the other side. Similarly, same thing here. And so this is how this type of gear allows a car to go around a turn, or allows its wheels to rotate at different speeds, which is important for how it functions and performs as a car. And this one's complete and ready for use. So I'll press and hold Control and then tap S, and that completes the demonstration of how to use the advanced gear set.